So welcome. Thank you so much for joining us for this webinar introducing panLab 3. I am Dan Higgett, and I am the Director of Innovate Audio and the creators who are the creators of the panLab line of spatial audio solutions. We've just released a new product, panLab Console, which basically applies our kind of logic for spatial audio directly to mixing consoles. This webinar is not going to cover panLab Console. So if you're interested in learning a bit more about panLab Console, which is live spatial audio directly to mixing consoles, then I will email everyone who's signed up to this one just to let them know when we'll run that webinar. But this is panLab 3, which is our spatial audio imaging solution that integrates seamlessly with QLab. Basically by the end of this webinar, I'm really hoping that you feel confident to go and add spatial audio to your QLab sound design workflow. And so it's going to be quite a practical demonstration. We're going to start with some basic kind of key concepts and terminologies. So some of the words that we're going to be using when we're dealing with the application. And then we're going to work on some real practical stuff. So system tuning, how to integrate panLab Console when you're tuning a system, and then adding panLab Console into your sound design workflow. Just a few more people just being admitted to the waiting room. And then, so after we've looked at just sort of the practical adding panLab Console into your panLab 3 into your sound design workflow, we're going to look at some of the more advanced features. So the multi-channel algorithm, which is essentially how we deal with multi-channel QLab Cues. And then dynamic spatialisation, which is a fancy way of saying moving sounds around within your sound design in a feature that we call sequences. Derived outputs, which are essentially sort of spatialized auxiliary sends, so kind of post-fade auxiliary sends that are kind of spatialized, which we'll talk about a little bit later. So that's kind of how that you might deal with subwoofers, for example, or potentially stereo down mixes of your surround sound mix. And then we'll end up with a question and answer session. So it's actually, normally I do this with my brother, Oscar, but he's not able to join the call today. So if you drop any messages, any questions into the chat, at the end, I will be monitoring the chat and also any live questions that you've got. But without further ado, let's jump in. So what is panLab 3? panLab 3 is our spatial audio solution that's designed to work with QLab. So if you've designed sound with QLab, you'll be familiar with little kind of faders at the bottom of the screen, and that's how you kind of distribute your audio around your sound system using QLab. And basically, I really wanted to work with spatial audio as a sound designer, and I worked with QLab as part of all of my sound design. And so I wanted to add that functionality into QLab. And so we've built our own spatial audio algorithm. And essentially, we allow you to design your own bespoke spatial environments, and we essentially print that data, that spatial data, back into QLab. So we're basically creating a panner that you can apply to QLab, and it's a whole new way of interacting with audio and QLab. So as a sound designer, I'm very familiar with the kind of speed that we all need to work at when we're working, particularly in theatrical sound design. Just admit someone else to the room. And so I wanted this solution to be super quick to set up. So every time we've added a new feature to panLab, we've always been against the benchmark of could we still set this solution up in 5 minutes? So 5-minute flat setup is essentially the aim of the game here. And also additionally, panLab is the only spatial audio solution on the market that not only doesn't require any additional hardware, it doesn't even require any additional software to be running during performances. And that's because essentially we print all of that spatial data back into QLab in the form of QLab Cues. So when you're ready to run your performance, you can just quit panLab and let QLab do all the heavy lifting. So it's kind of a fairly unique take on spatial audio that I'm hoping people are excited about. So let's have a look at some key concepts and some terminology that we use within panLab that you'll come across. So first of all, a map. So when you think of a panner, everything within that panner is essentially contained within a map. So a panLab 3 file can contain multiple maps, which could be useful in some niche cases, but most of the time you'll just need to be creating a single map, and the map contains all of the objects within the panner. So the objects in the panner are very simply speakers and QLab Cues. Those are the two types of objects that you're going to be interacting with. Speakers in the panner are organized into zones. And so a zone is essentially our way of letting you let us know how your speakers should be grouped together. What kind of logical grouping do you have? So I've got some additional slides in a second that kind of illustrate the points of zones a bit better, but essentially think of a zone as a group of speakers that you want to pan a sound around. And finally, just the terminology of speakers. When I talk about a speaker, it basically just represents a QLab Cue output. So say you had a QLab Cue output that was called proscenium left, that would be represented as a speaker. But essentially, when we talk about a speaker, we're just communicating with that QLab Cue output. So let's have a look at a little bit at the terminology of zones. A zone, so if you think about a quad panner, that would be a square, or a 5.1 or a 7.1 panner, that would be a square. A zone is essentially a panner on steroids in that it is a polygon shape, and it's whatever shape is made up of all of the speakers that you place in it. So instead of being a square, this polygon shape is the shape of all of these 10 speakers that you've placed in it. So at the moment, just for this demonstration, it's just a random shape. And what we actually do is we calculate the geographical center of the zone. So that's really important in the sense of this 5-minute setup, in that we're working out the relationship between all of these speakers for you. And we do that, the key thing that we're doing here is working out the geographical center of the zone for you. And what I mean by that is if you had a piece of paper and you held that up with your finger in the middle of it, where's the geographical center? Where would you be able to balance that sheet of paper if this zone, this polygon shape was a sheet of paper? And what that allows us to do is work out the relationship between all the speakers. And so what we can do is if you place a sound towards the edge of the zone, let's just say we place this sound between speakers 1 and 2, essentially we're going to be panning the sound mostly between speaker 1 and speaker 2. And in this kind of example, you're looking at, you'd probably be panning in the middle of speaker 1 and speaker 2. But as you move that sound towards the center of the zone, we actually spread out where that sound's coming from until you're panning between all of the speakers in the zone. And so because we've worked out that center, we can work out the relationship, and allows us to create these big customized panners, these big customized zones that you can essentially pan the sound around. The other really important feature of a zone is we have added this concept of a zone boundary. So when you've got the sound within the zone, so if you put your source somewhere in the middle of that polygon shape, we do what's called equal power panning. We essentially normalize the sound level to be a constant level wherever you move your sound within the zone. As soon as you move the sound out of the zone and through this area that we call the zone boundary, essentially the influence of that zone diminishes, and essentially you're fading the sound down out of that zone as you move the sound further away from the zone. And that's really important because it allows you to layer multiple zones together on a panner. So this is the example I always give, which is an auditorium zone and a stage zone. So essentially you've got a stage zone, which is 4 speakers, which we're going to actually build in a little bit, and an auditorium zone, which is all your front of house speakers. And because we've layered those two zones over the top of each other with a zone boundary, you could actually move a sound all the way from the back of your stage to the back of your auditorium with equal power panning, essentially. So you can create your own customizable spatial environments. So I think that's probably it for slides, and the slides that you actually saw there. And so let's just move on to... oh, look, admit someone else to the room. Let's move on to the actual interface itself. We're looking at my screen, hopefully, still, and we've got two windows. We've got QLab, which you'll be familiar with, and we've got panLab 3 running here. So let's just run you through the user interface quickly. In the center here, we have what's going to become the panner. So we're going to add all of the objects we need to into that in a moment. On the left of the screen here, this list is going to be a list of all of the currently selected audio cues that we're going to be working with in the panner. And on the right, this window here is going to basically be an inspector of the currently selected audio cue. And we're going to be able to do things like change the level of it and create sequences so we can create movements in the space. So the very first thing we need to do when we create a new panLab file is connect to into the QLab workspace we want to be working with. So panLab actually connects over the local area network using OSC. And so we actually need to create that connection. We don't actually need panLab 3 to be running on the same Mac as QLab. We are here just because I can share one screen with you. But we don't need to be. This could be on your production desk with your QLab computer running at your console. But when we hit this connect button, panLab is going to scour the network for any open QLab workspaces. This is the only one that's on this network at my house, so we can connect and link to it. Because we're running QLab 5, I need to put in a passcode, which you may or may not need to do. So yeah, so the first thing we're prompted to do is create a new map. I mentioned earlier that you can actually have multiple maps within a file. So that is useful if you have, say, an immersive experience where you have multiple different discrete rooms. You might want to have a map for each room. But in this example, we're just going to create a standard theatre auditorium. So I'm going to call my map auditorium. And that's going to create, this is going to be the one kind of spatial environment that we're going to create with this file. So the first thing we might want to do is add a backing image to the panner so we can kind of visualize where we're placing our speakers and our objects. So basically you can add any image file onto the backing image. It's an advantage if it's square because the panner is always square, but if it's not quite square, we can, size it to fit. And this basically allows us to visualize where we're going to be placing our objects. This is just some theatre plan that I happen to have on my computer. And then the next thing we need to do is we need to add speakers. So we've created our first map. When we create the map, panLab has created our first zone for us. So this first zone is going to have all of our front of house loudspeakers in. So I'm just going to label it front of house. And if I hit the add speaker button here, you'll see that panLab 3 is actually populating this list of speakers with the available QLab Cue outputs. So if I go over to QLab, I have a look at my QLab Cue outputs. All I've done in this file is just label these QLab Cue outputs with some appropriate names. And because I've done that, panLab 3 has pulled those names into this interface and is allowing us to add them to the panner. So if I just hit add speaker a few times, I'm just going to add in all of my front of house loudspeakers into this list for this zone of, list of speakers in this zone. And then all I need to do is drag and drop them onto the panner. You'll see as I add them onto the panner, I'm getting this visualization. I can turn down the opacity of the visualization just to make things easier, and I'll just show you what that means in a little bit, but essentially it's visualizing the zone that we're creating and the influence of that zone. So let's add our side surround speakers and our rear surround speakers. So if I turn the opacity up, so you can kind of just see what's going on here. And I'm going to turn, this is where we set the size of the zone boundary that I talked about. So let's turn that down to 0. So you'll see that this zone is a 6-sided shape, essentially, and it's the shape of all of the speakers I've added into the zone. And because I've turned the zone boundary size down to 0, essentially if I added a sound into this zone and moved it around, I'd be outputting at a constant level. That would be worked out between all of these 6 speakers. And if I move that sound out of the zone, it would essentially just cut off. So it's useful to kind of just see exactly where the zone is, but I want to give the zone a bit of a boundary so that we have a bit of a blend between zones. And the next thing I want to do is just add our stage zone. So let's call that stage. And again, just hit add speaker button. I've got 4 speakers on my stage. So add that 4 times and add that downstage left, downstage right, upstage left, and upstage right. panLab will actually just pick a random color, and we've got these 2 colors right now. So essentially, you can see a couple of things going on. So now we've got this visualization that I've left kind of up so you can see what's happening. And you can see that the auditorium zone actually kind of extends over the stage zone. The influence of it kind of extends onto the stage. And if I was to adjust the size of the zone boundary, the size of that influence out onto the stage decreases. And I can do the same thing for my stage zone. I can just make that a little bit smaller. And you can see I've got this overlap between these 2 zones. I can actually change this so it's the other way around. I can change the order of the zones. So if I just make this a bit bigger so it's clearer, if I drag the front of house zone in this table below the stage zone, you can see that the way those 2 zones are interacting has actually changed. And now the stage zone, the pink area of the stage zone is actually above the front of house zone in my visualization here. And that is basically accurately reflecting how the energy is going to be distributed between these 2 zones. So let's move, typically I have the stage zone over the top, so let's just set this back to typically how I'd want it. So let's just move on now to practically implementing panLab into your workflow. So we've created our spatial audio environment, and now we want to actually work with it in a creative way. So the first thing we want to do is add a sound. And we've created multiple ways that you can actually add a sound onto the panel. Because we are on the same computer, the easiest way is actually I can just drag and drop the sound onto the panel. And you'll notice that as soon as I do so, we've actually immediately started updating the crosspoint levels here based on our spatial algorithm. So if I move these around, you can see what I mean. So that's the easiest way. The other way is we can select a sound in QLab, and then we can hit this Fetch Selected Audio Cues button. So if I hit that, then the selected audio cue is added to the list, and I can drag it in. So if you're working on a different computer, that's one way of doing it. The final way is you can actually, there's an OSC dictionary, which if I drag the window onto the screen here, you can get from our website. And one of the useful OSC hooks is the Fetch Cues OSC hook. So I've actually set that up already. So I can, in QLab, I can create an OSC outputs, which is essentially, in fact, panLab is already built into, it's part of the infrastructure in QLab 5. You can actually just select the output patch to be a panLab 2 output patch. And you can have it output fetch selected cues. So if you trigger that cue with, say, a hotkey and go back to my audio list, I should be able to, let's say I was working in here, I should be able to hit 1 because that's the hotkey that triggers that OSC cue, and soundcheck song has now been selected on the panel there. So there are multiple ways that you can basically quickly and easily add your cues into the panel. But practically speaking, how do you go about adding panLab into your sound design workflow? The first thing that you want to do is you want to commission your sound system. So you want to be using panLab whilst you're commissioning your sound system, because the key thing that you want to achieve is that equal power panning. And what that means is that if you move a sound object anywhere on this panel within one of these zones, you want to be hearing with your ears an equal amount of output power. So if your pros, for example, is a little bit hotter because you've got bigger, punchier speakers in your pros than your side surrounds and your rear surrounds, you need to be able to offset that level difference somewhere using some kind of gain stage. So that could be on an amplifier, it could be on your QLab desk channels on the console, wherever that might be. You want to basically be able to balance out your sound system. So typically what you might want to do is you want to get your sound check song that you're using as part of your sound check, and you want to just play it and add it to the panel, and you can just literally just move that sound around and have a listen to what's going on in your sound system when you move it onto the stage, when you move it into your auditorium. You want to just be able to create complete equal power, or as much as possible, equal power panning wherever you move your sound in panLab 3. So if you need to, so as I say, ideally you create that gain structure. You'd fix that gain structure issue if you have one somewhere outside of panLab. But actually in panLab, in the map manager, each speaker can have its own dB offset value. So you'll see that as I move this slider down, if you have a look down here, on the actual crosspoint level that we're outdating, you can see that as I move the slider, we're actually changing the output that we're sending to QLab. So you can create an offset, a dB offset for each speaker, and indeed for each zone within panLab if you need to balance things up. So you've got that option in panLab, but ideally you'd balance out your sound system somewhere else. Once you're completely happy with how your sound system is behaving, I'd advise you to lock the map using this little lock icon here in the map manager. And that basically prevents any further changes to the position of any of the speakers or any accidental changes like that. It just locks everything down. So now the only things I can move on the panel is the sound objects. I can't, if I click on this speaker, for example, I can't change the position of the pros speaker. It's just locked in place. So just practically speaking, once you're happy with how your sound system is handling things, just lock it down, and that just prevents any unnecessary changes. Right, so you're basically designing away, and you're adding sounds onto the panel. What have I got to talk about next? Oh yeah, the next thing we need to handle is the derived outputs. So a derived output, in fact, let's see if I've got a slide for that. I think I might do, Yeah, here we are. So a derived output is essentially an additional QLab Cue output where the level we're sending is derived from the level we're sending to other outputs. So it's essentially a kind of a spatialized output. So if our algorithm is calculating that we need to send this much level to this set of outputs, then we'll sort of copy that level over to a derived output. And the thing it's most useful for handling is essentially subwoofers or any other subsystem of your main sound system, like delay lines or potentially a stereo mixdown of whatever you're outputting to the rest of your system. And so panLab actually allows for 8 derived outputs to be set up. So if we go back over to the map manager, and if we unlock our map, we've got this Assign Derived Output button here within the map manager. So if I click on that, we need to give our derived output a name. So let's call it subs. It needs to be routed out to a QLab Cue output. So this name we give it in this route to QLab Cue output, this name needs to match up with an output name in QLab. So if I just go and check, I think I've called it subs. So it's actually the same. So let's call it subs. And that matches up. And then we've got this button that allows us to assign how we're deriving this sub output. So in this example, let's just say we've got a sub output and we want it to be derived from all of our front of house loudspeakers. So let's check all these boxes on and hit done. And then let's lock our map again. And now if I go back to this sound check song, let's turn my subs up to 0. Let's add it into the panel. We've got, just to introduce you to another bit of the user interface, when you have a sound in the panel here, you get these 2 little icons here. And this one that looks like kind of sliders is our kind of mixer window. And it's the mixer window for this particular cue. So what we can do is our first derived output is listed here and it's subs, and we can turn that up to 0 or thereabouts. And then if I go back to QLab, you'll see that we're outputting, it's actually -14, and that's because we're at -10 and we're summing those 2 channels together. Someone else is just being omitted. So if I was to move this over a little bit, and move this sound here. Now you see that the sub output is at -4. Wherever I place this sound on the panner, all of our front of house zone speakers are all changing level depending on where we are, but the sub output is staying at -4. If I move the sound out of the front of house zone onto our stage zone, our level out to the subs is also decreasing now, along with the level out to all of the other speakers in our front of house zone, and that's because we're not deriving the sub level from any of our stage speakers. So it's the same if I move it this way. As we fade the sound out from everywhere else, we're also fading it out of the subs. So it's kind of like a post-fade auxiliary send. So yeah, let's say we're happy with that and lock that. Oh no, it was locked. Lock that zone up one more time. So yeah, that is derived outputs. The other feature I want to talk to you about is multi-channel sources. So this is a new feature for panLab 3 that wasn't present in panLab 2. And in fact, we've been dealing with a multi-channel source, though I haven't explained it here in the panel. So when you think of a sound cue in QLab, quite often you're dealing with stereo files as an example. And you need to be able to spatialize essentially both channels of that stereo file. And that's essentially what we got here. We've got a soundcheck song. And so not only do we have this one point on the panel, which is the actual cue itself, we've got a few other things going on. We've got, if I zoom in, so you can see it a little bit easier, we've got actually positions for the left channel, channel 1, and the right channel, channel 2. And we've also got this direction handle here. And what that allows us to do is if I move the direction handle, we can actually move the positions of the left channel and the right channel. So if I make this super obvious, and we can also adjust these things, so the angle and the spread of the sound from this panel here, which is essentially our layout manager for this source. So if I spread these really wide, you can see that, and let's move that up here, you can see that now the left-hand channel, so input channel 1 is going to the pros left, and input channel 2 of this sound file is going to the pros right. So it's at -5.4 and -6.2. If I was to move that more into the middle, eventually it would match up and be the same level in both. If I bring the width in, which I can do either by dragging on this D handle here, or if it's a bit too big, I can do it from its own UI. I can actually just mono this source up, and essentially now we've turned that stereo file into a mono file in the middle of our panel here, and essentially the left input is going to both sides, left and right, and if I was to move this file over to the left, then most of the energy is now just distributed to the pros left speaker. So that is a fairly simple example, which is a stereo file, but we actually handle any number of inputs from 1 through to 24 can be multi-channel inputs, for example. So if I was to select this cue, which is actually a 5.1 cue, you can see that I don't just have a stereo, I've got all 5.1 channels of this sound file essentially can be rendered onto our custom sound system that we've designed here. So we could, make this nice and big and put our left, center, right channels near the pros left and right, and our rear left and right channels onto the rear left and right as an example. And that is actually where this layout manager window comes into its own a little bit, because we can actually change the positions of any of these 6 channels in our file, and we can change which channel is the LFE channel. At the moment it's channel 4, but we could change that to be channel 6 if we wanted, and then channel 4 turns up, or we can put it back to channel 4, which I think is what it is in this file. And then we can basically choose how we deal with that LFE channel. So because we've set up derived output 1 as the sub output, we can check that our LFE channel wants to be routed to derived output 1, and we could turn that up. Let's just turn it up to 0. And then if we have a look at our cross points in QLab, you'll see that channel 4 of this multi-channel file is just going to the subs, so that just needs to be turned up in this case. and the rest of the channels are being spatialized onto the rest of our sound system. If I was to zoom out a little bit and move this 5.1 channel out of the sound system, the level that we're sending goes away to nothing everywhere, basically, because we've moved it outside of that zone. And as soon as I bring it in, we start outputting level to the appropriate places. So that's a pretty powerful new feature, and it allows you to essentially spatialize any number of input channels against any number of the output channels that are actually physically present in your sound system. And I think that moves us on to sequences. So, I think I've got a slide for that. Let's bring it up. Here we are. So sequences are our kind of dynamic spatialization functionality. So I mentioned before at the beginning of the call that you don't need to have panLab running when your show's running. And that's because actually what we're doing is printing all of that spatial data. So not only the data related to the audio cue itself, but any movement data we can actually print into QLab. And we do that with sequences, and sequences in QLab are actually group cues containing a huge number of fade cues, and each fade cue can be positioned on the panner. So that's essentially what we're doing with sequences. So let's create one. So let's go back to our audio, and should we work with our sound check song? Let's work with our sound check song. So we've got a track here that we want to move around as part of our sound design. And so what we can do is, let's say we want it to start over here by the pros left. We can just position that sound, make sure we're happy with where it's coming from at the beginning of a sequence. And then with the sound selected here, so when it's selected, it's just highlighted in blue, and also it turns up in the right panel here. We can create this Create Sequence button. And what that's done is it's created a new sequence that's called New Sequence, and it's also created a corresponding group cue and a fade cue, and it's given us our first fade in QLab for us. So it's created that first bit of movement for us. So let's give this sequence a name first. Let's call it Zoom Around. And let's move this fade into a sensible position. So let's say we're going to go clockwise around the panner here. So we'll get that fade into a useful position, and then what we can do is hit the Draw Path button. And you'll see that we're immediately prompted to, I'll just zoom in so you can see it a bit better, move this object to record some movement automation. So let's do that. So I'm going to just click and drag and move it around the panner. And you'll see that as I move it, we're creating these fade cues. They're not actually being printed into QLab yet, and that's fine. They're just being represented there. But as soon as I release the mouse, you'll see that all of these fade cues have been printed into QLab as 30 fade cues. And what we've actually recorded is not only the position of my movement, so the fact that I went in this kind of square shape, but also the timing. So it took me 12 point something seconds to draw all of these paths. And as I sped up and slowed down, that sound object would have sped up and slowed down. And in fact, as I moved it, if I was listening to it, I'd be able to hear that movement in the sound system. So that means that I can essentially create that movement, hear it as I'm creating it, and then play it back by simply pressing play in QLab. And that will essentially run all those fades. It's part of this group cue. And what you'd be hearing is the sound, this sound check song, moving around my panner. Let's stop that playing in there. There's a few things I can do to this. First of all, I can change the duration of it. So let's say this was from some big sound effect and the director really liked it, but it was a little bit quick. We could type in 15 for 15 seconds into the duration box, hit enter, and we're given an option of either changing this with a constant speed of movement, or say we liked the speed of, the changes of speed that we had going on, we could adjust that proportionally. And essentially now we've changed the duration of that sequence to 15 seconds, but maintained the proportional changes of movement that we had before. The other thing we can do is move any of these fades in the panner. If we want to just adjust how this thing moves around, we can move the fades. And that will just change where this sound is going. So that's really neat. And we can also copy and paste this sequence between sources as well. So we can apply this same sequence to any other number of sources. So I've been talking now for about 40 minutes. And I kind of wanted this session to be about 45 minutes just so it's accessible to lots of folk. So there's lots more I can talk about, but I just thought maybe at this point I could see if I can actually work this and open up the chat. And yeah, so basically just see if you guys have got any questions before I go on. Can I simplify a sequence to reduce the number of points and fade cues? Yes, you can. Good question. So first of all, you can delete fades from in here. So let's say I wanted to delete fade 5. I could do that. So that's just pulled fade 5 out of there. So I could delete some fades like that. That's absolutely fine. The other option you've got is, which is relevant before you actually start recording it, is if you go to the panLab 3 menu and go to settings, you can actually change the distance between the fades for drawn sequences. So at the moment it's on short, but if I change that to medium or long, it would mean that the sort of density of fades would decrease. Typically, actually, for the most accurate panning, you want a higher density of fades. The only trade-off there is really just the workload that you're putting on QLab. So if you find that QLab's struggling because you've just asked it to record 500 cues, 500 fades, you might want to lower the distance between fades as an option. But typically, that's not really a problem on most modern Macs, and you probably want a higher density of fades. Yes, absolutely. So the question is, are the parameters of the sequence automatically updated in QLab? The answer is yes. So, for example, I just deleted fade 5 from there. You can see that in QLab we jumped from fade 4 to fade 6. As let's move fade 6 around, you can see if you have a look at the levels, as soon as I'm moving fade 6, obviously all those crosspoint levels are updating. I could rename fade 6 to fade test, and you'll see that the name of fade 6 is updated to fade test. I can change the name of this sequence in QLab to zoom around 2, and that should have updated, but it didn't. The other thing that you can do is, if I delete a bunch of these fades from here, panLab actually keeps track of whether the fades exist or not within the QLab workspace, and you'll see that you get these error warning triangles because these fades, which should exist in this sequence, fades 15 through to 29, don't currently exist in QLab. So what we can do is actually hit the sync to workspace button, and QLab will just try and rebuild that sequence for you in QLab. So if you ever accidentally delete some data from QLab, you can always put it back in. Is there limitations to how many channel output speakers you can put on a map, like 20 or 40 speakers? No. The limitation is purely QLab's, so I think it's 64 QLab Cue outputs that you can have at the moment. So the total number of outputs that you could map is 64, I believe, but that's a QLab limitation rather than a panLab limitation. But good question. Any other questions? There's a few other bits I can point out, but if anyone's got any more questions now, let me know. Cool. The next thing I can just chat about quickly then is zone opacity. So let's close this up. This might be something that's useful to folk. So when you're looking at a map, you're looking at all of your zones at an equal level. So it's basically, if you think about, literally with the visualization, you're getting a kind of a picture almost of how your sound system's going to work together, the spatial environment's going to work together. And we've got two zones going on here that have got a bit of an overlap. But what you can actually do is change the opacity on a cue by cue basis of each zone. So let's say, for example, we want the sound check song to be here, and it's kind of on stage, but because our front of house zone is over the top of our stage zone, if you have a look at our output power, it's still mostly distributing our output energy into the pros left and right, because this front of house zone is above our stage zone. In fact, what I'll do just to demonstrate this, I'm just going to make this a little bit smaller. Make it a little bit smaller like that. There we go, that's a bit better. What we've actually got is a zone opacity property here for each zone. And we can actually turn down the opacity of our front of house zone. And we should see, if we have a look in QLab, that because the opacity of the front of house zone is now 0, even though this track is in the middle of the pros left and right speakers, and we should be hearing it in the pros left and right, because we've turned the opacity of the front of house zone down, this sound is now only coming down out of the downstage left and right speakers. So this is another property on a cue by cue basis that you can use to change how each individual cue interacts with your sound system. And where that actually comes into its own, which I haven't built here, is if you're working with overhead zones. So if you had another overhead front of house zone here with maybe some overhead speakers, you could, by changing the opacity of the overhead zone, you could determine whether a sound was in the overhead loudspeakers or the side surround loudspeakers. So you could change the height of the sound, essentially. Okay, cool. I've had a couple of good questions. So, is the panning math based on or inspired at all on the Mayer spatialisation from Dimitri LCS or more currently SpaceMap Go? No, but actually, interestingly, my understanding is those two solutions, SpaceMap Go is born out of Dimitri and LCS. No, it isn't actually at all. Though they've got a really neat solution. The reason why it isn't is because we're totally kind of committed to this 5-minute setup. And what you don't really get with SpaceMap Go is, it kind of tries to automatically do it for you, but you don't get, it doesn't particularly determine for you the relationship between the loudspeakers, whereas we do. So with a zone concept, as I kind of explained before, we're working out for you the relationship between in this case, the 6 loudspeakers in this zone. So it's actually, it's doing a similar thing in the sense that both of those examples that you give and this are amplitude-based panning algorithms. And SpaceMap is also like an equal power panning, so they'll try and do the normalization for you as well. But where we're kind of going further in that respect is we're working out, as it's just baked into the algorithm, we're working out the relationship between all these loudspeakers for you. But good question. Also a question about OSC. If you have a movement detector on the space, can panLab work in real time so that the playback voice follows the person moving on in the space? So technically, yes, but this is kind of why we built the panLab console, which is our software which works with live audio, and it essentially applies the same panning algorithm that we've developed here, but directly to mixing consoles. So I say technically yes, because it can do that, and there is part of the OSC dictionary, if I just pull it up on the screen, is we can change the, the position. So you've got position, here we are, position. So you can set the position variable of the XY coordinates of any currently selected cue. However, there's a caveat to this. QLab is actually not all that great at handling high volumes of OSC. So if you think every time we change the position of a sound in here, we actually have to send quite a high volume of OSC to QLab in order to do that. You run the risk that QLab will actually just kind of choke up a little bit if you're trying to do that live. So I try and steer away from that. But if you want to do that kind of thing, then you're probably more interested in panLab console, which we've only just released literally a few weeks ago, which essentially applies the same algorithm, but we adjust the input channel to auxiliary sends of a mixing console. And we can do that live and in real time. And consoles typically are much, much faster than computers at just handling the kind of volumes of OSC that I need to send of it to get it to live track. So let me just see if there's other questions. Can you update the map for different venues over your cues? Yes. So you can create multiple maps. So if you've got different venues, so like the example I would give would be like an immersive experience where you've got multiple kind of immersive rooms which are completely different spatial environments. A single panLab file that's communicating with a single QLab workspace can contain multiple maps. And so a map is essentially everything that you see in this central section of the panel here. And so if you had a QLab workspace that was actually responsible for multiple different rooms, I'd say put each of those rooms into their own map. And then basically each map is a kind of its own silo of information, and it doesn't really care about what's happening in the other maps. So I think that makes the most logical sense. You could, of course, just create a load more detail in here and just have, each of the, you just put a bigger plan that, contain multiple rooms, and then you could move the sound between multiple rooms on one map, and you could just turn down the, zone boundaries so they didn't conflict with each other, but it starts to get a bit messy, and I'd probably divide them up if I was you. Let me just see if I missed any questions. So it's just me today. Can parameters of the sequence be controlled externally via OSC? I mean, sort of, but it sort of goes back to doing it live is a bit of a risk. But yes, the parameters, not to a great extent, but you can change like the position of stuff via OSC. You can also recall a sequence via OSC. But it's more to do with your sound design. That's more of a workflow thing rather than a creative, let's do this live kind of thing. Any more questions before we end this up? Okay, yes. Would it be worthy to introduce delay time parameters applied to the cue outputs as well as the audio level parameters within the movement of a sound object? Yeah, good question. So this is purely amplitude-based panning. And there's a very good reason for that. Which is that 5-minute setup. You can't, as soon as you need to add delay in, you need to know the exact XY coordinates of all of your speakers and the distances between them, and it just becomes a lot more challenging. Secondly, actually, you can't, on a cue-by-cue basis anyway, update delay times in QLab. That's not a possibility. So I couldn't do I couldn't do that if I wanted to from a limitation with QLab perspective. But actually, in order to get the 5-minute setup, it needs to be an amplitude-based panning algorithm. Cool. Thank you so much for coming, everyone. I've got one last slide, which is the end slide. Because just to say thanks for coming and watching the demo and all of that. If you wanted to purchase panLab 3, you can use this coupon code, which is WEB20, and that gives you a 20% discount off any panLab 3 or indeed panLab 2 license for this next week. You can buy that via the website, innovateaudio.co.uk, or in-app. So there's an in-app purchase option. You can, just in terms of getting your hands on panLab 3, you can download it for free, and you get a 7-day trial of the full connectivity to QLab for 7 days. So yeah, so if at the end of that trial you wanted to purchase it for this next week, there's a 20% discount available. So yeah, thank you so much for coming. I really appreciate your time, and hope that was useful for everyone. Thank you.